This video will cover using transformations to graph quadratic functions, which is lesson 5-1. So what we're going to look at here is what's called the vertex form of a quadratic function. The reason it's called a vertex form is because with this form you can spot the h or the x value of the vertex of the graph and the y value. And we refer to those as h and k. The h value is the x coordinate of the vertex and the k is the y coordinate. There is one other variable here that manipulates this graph, and that will be a, and that's the first thing we're going to talk about. We're always going to be comparing the manipulation of a, h, and k as it compares to the parent function f of x is equal to x squared. Now I think it's important to note with this particular parent function what those a, h, and k values actually are. Well, in this case, a is 1. 1 is in front of the parentheses of whatever x minus h might be squared, and there's nothing written there, so the assumption is that there is a 1 there. The h value, well, since there's nothing inside of parentheses, must be 0, and the k value, since there's nothing there as well, must also be 0. So if you don't see a k value, or if you don't see a parentheses with the x inside of it, then it tells you that the h is 0, and if there's nothing out here, the k is 0. So the vertex here is at 0, 0, and that's a very important thing to be able to spot. So let's take a look at what a does in the equation, and there's a couple rules or a couple things it does, and again, a is the variable or the letter that is holding the place in front of the x minus h. First is, if a is negative, the parabola is upside down. So what we're talking about here is parabolas, and if a is negative, then the parabola is upside down. If a is greater than 1 or less than negative 1, it stretches the graph. And if a is between -1 and 1, the parabola is compressed. And so we're going to show how those things really work. So let me pull up what we have here is Geometry Sketchpad. And what you see is right now I have the parent function where a is 1, the h value is 0, and the k value is 0. So you'll see that this is a parabola where the vertex is at 0. And what we're going to do is we're going to manipulate the a, and we're going to show how it works. If I were to say make a greater than 1, say up to 2, my claim is that it would stretch. So let's do that. Let's go right to 2. And you can see that what it looks like is, from a horizontal standpoint, that the graph is being squished together. But think of it from a vertical standpoint, like I was holding onto the vertex and I was pulling up. It's actually stretching the graph. So let's watch that happen again. So I go to 1, and I go to 2 now, and it stretches the graph. So if I make a, say, 3, as you can see up here, then I'm stretching the graph even more. And as I increase the number here that a is, I'm stretching and stretching and stretching. So let's go back the other way now, and let's look at negative values. Let's say a was -1. Well, it's not stretched any more or any less than the parent function would be. All we've done is reflected across the x-axis, or about. It's upside down now. So when a is negative, it flips it upside down, and then if a is, say, -2, it's stretching it again, but it's stretching it downward. And if a is, say, I can keep going and going and going, the bigger that a gets, the more it stretches it. So now let's take a look at numbers between 1 and -1. So let's start with a at 1. And if I start to go to a number between that's smaller than 1, you can see that the graph is actually getting, instead of stretching, it's actually doing the opposite, or what I would call compressing. And it gets fatter and or wider as I push down. It's like a bowl that I'm pushing down on, or a string that I'm just laying down. I'm compressing it. One thing I want to point out to you is what happens if a goes to 0. If a goes to 0, then it becomes a flat line and it's no longer a parabola, because 0 times the x squared would give you 0. And so the actual equation would be y is equal to 0. So any number other than 0 it's a parabola, but in between -1 and 1, it's a compressed graph. So I'll go over to -1 and I'll go backwards there. So you see from -1, if I go back, it compresses and compresses and compresses and compresses. So now back at the notes, what I'd like to do with examples 1 through 4 here is talk about what we think will happen to A as we make changes here. So the first thing I want to do is say, okay, well, what is A here? A in this equation is going to be -1. And what does that do to the graph? It actually reflects it. So let's now take a look at problem examples 1 through 4. What I want to do is compare the f of x to the g of x. The f of x will be, in this case, our parent function in each case, and our g of x will be something that has been manipulated on the a, and we want to talk about what really happens when that occurs. So a and g of x this time will be -1, and what does that do? It reflects across the axis, or flips the parabola upside down. So reflects across x-axis. In this case here, example 2, a is 3. It doesn't reflect. Compared to the parent function, all it does is stretch by a factor of 3. This next case over here, example 3, a is a -2, and two things are happening here. First off, it reflects. Reflects across the x-axis. And stretches by 2, a factor of 2. Oops. This last one here, a is 0.5, and in this case it compresses compared to the f of x. It actually gets flatter by a half, by a factor of a half. So what we talk about with the a values, remember that if it's negative, it flips the parabola upside down. If a is greater than 1 or less than -1, the graph is stretching. If a is between -1 and 1, it's compressing it compared to the parent function. And these are all comparisons to the parent function.